Hey guys, I hope you're doing great. So today we'll be solving another Leetcode problem, that is to find the minimum depth of a binary tree. The problem here says that given a binary tree, find its minimum depth. The minimum depth is the number of nodes along the shortest path from the root node to the nearest leaf node. Note that a leaf node is the node with no children. For example, the leaf node here in example 1 is actually 9 because it doesn't have any left or right. But if we come to the right node which has a value of 20, it has a node to the left as well as to the right. Now we might encounter a situation where this node would have some value, for example 16, and if we count the number of levels, so this is level 1, this is level 2, this is level 3, and this would become level 4. So we need to find the minimum depth or the minimum or the nearest leaf node. If I say it, find the nearest leaf node. The problem itself is quite self-explanatory, that, and we'll be using the breadth first search or BFS. So traversal, level by level traversal, to find our nearest leaf node. Now, as we know that in a level by level traversal, we'll start here, which is level 1, and we'll use a queue structure, and we'll add all the child elements of the current node. Then we'll move on and we'll pop off this element from the queue. Then we'll move on to the next element and we'll add the children. If it doesn't have any left or right nodes, we can simply return our answer right at this point without doing any further calculations. But let's see here, there was another example of this test case 2. I hope it's visible, guys, that the nodes only have the right nodes to go on, the right childs. So even though it doesn't have a left, this doesn't have a left, neither one of these has a left node, but the levels are still increasing. This is level 1, this is level 2, this is level 3, level 4, and level 5. So the answer to this would be 5, and the answer to the above case would be level 2, because the root node is level 1, and then this is level 2, the root node is level 1, the next is level 2, the third is level 3, and if there's any and if there is any child node present, then that would become level 4. So I hope that clears up this up our logic, that we have to go level by level and find the node which doesn't have any child nodes. Then that would be our nearest leaf node. So let's get to the solution. We will be using a list as a queue. The queue uses the first in, first out logic. So we'll be appending the elements to the end and popping at the start to in place this logic. And the queue will be initialized with the root. But there is a constraint here that says that the number of nodes in the tree can be from 0 to 10 to the power 5. The value can be from minus 1000 to 1000, which means that we can have a root node which is a null. And there is no value, because that is this example, there is no root, it's empty. So we can simply check it in the first line. If not root, then we'll simply return level, then we'll simply return a 0 because it doesn't have any levels. But if it does, then we'll initialize our queue and we'll initialize our level to 1. And then we will go level by level and we'll keep on adding and popping the elements from the queue in first in, first out order. And the first in is the root. And we have to check all of the elements in the queue at the current time. So we'll take a snapshot of the length of the queue and then iterate over the queue as many times. And each time we'll take the element from the queue and remove the first element. Now we'll check if the node dot left is empty, which means if there's nothing here, if this is true, and if the node to the right is also empty, then we'll simply return level plus 1. We'll initialize the level with a 0 here. And we'll update our levels as we traverse. Then we'll add another if statement. If node dot left, if there is a left node, then we'll append it to the queue and we'll append the left node. Similarly, if there is a node towards the right, then we'll add that to the queue as well. And after the current level, we have finished traversing the current level, we will increase the level by 1. And as we saw in the case 2, there were only right nodes. That means we'll be traversing throughout from the root towards the last leaf node, which is number 6. So the value we'll be returning is actually the level, which will be 6. Okay, let's try running this algorithm. And it passes all of the cases. We'll submit it just to make sure for me and yourself that this works. And it does. It has a pretty good runtime, but because we're using a bit of the memory, but the memory stuff is also okay. So that's it for the solution of this, to find the minimum depth of the binary tree. Hope that was helpful, and we'll see you again.